Okay, now we're about to start our fourth in the series of videos on database concepts and architecture. In the last lecture, we talked about the three schema architecture, which basically shows that there are three different views or several different views of a database meant for different constituencies. Some of you guys may be car guys, and so let's say, for example, that you have people looking at a particularly attractive car. Now, some of them are going to be very impressed with the motor that's in it, and they're going to be really paying attention to that car because of the engine. There'll be others that like the color, and then there'll be others that are particularly impressed with the electronics in that automobile. What we're about to address now is how the three schema architecture allows us to achieve data independence, essentially meaning that changes made in one schema should not affect the others. For example, with our car, if you change the color of the car, it won't have any effect on the electronics that are in the car or the engine that's in the car. Or if someone changes out the stereo in the automobile, well, that won't have any effect on the color or the engine. There is a certain amount of independence that you can make between these different modules. The three schema architecture can be used to further explain the concept of data independence, which can be defined as the capacity to change the schema at one level of the database system without having to change the schema at the next higher level. We will discuss two classifications of data independence. Logical data independence is the capacity to change the conceptual schema without having to change the external schemas or application programs. We may change the conceptual schema to expand the database by adding a record type or a data item, to change the constraints, or to reduce the database by removing a record type or data item. Only the view definition and the mappings need to be changed in the database management system that supports logical data independence. After the conceptual schema undergoes a logical reorganization, application programs that reference the external schema constructs must work as before. Now that we've described the terms internal schema, conceptual schema, and external schema, let's see if we can clarify by using an example. Let's say we have a record type or file or table, whatever term you want to use, called inventory that has 5 data items, fields, attributes. Once again, whatever you choose to call them. The 5 data items are part no, description, quantity on hand, cost, and price of our inventory file. We access the inventory file from a point of sale application that we've written. We decide that we need to track the vendors that we use, so we create another record type called vendors that contains several data items such as vendor ID, vendor name, contact, account number with that vendor, we'll call it account number, terms that we get from the vendor, so we'll have a data item called terms, and so on. We modify the record type inventory by adding another data item, vendor ID, that we're going to use to link to our new table, vendors. Because our system exhibits logical data independence, none of the changes that we have made should affect the function of our point of sale application. Changes to constraints can be applied to the conceptual schema without affecting the external schema or the application programs. Physical data independence is the capacity to change the internal schema without having to change the conceptual schema. Therefore, the external schemas need not be changed either. Changes to the internal schema may be needed because some new disk drives were added to reorganize the data files. One might do that to improve the performance of retrieval or update. If the same data as before remains in the database, we should not have to change our conceptual schema. Generally, physical data independence exists in most databases and file environments where physical details, such as the exact location of data on the disk and hardware details of storage, encoding, placement, compression, splitting, merging of records, and so on, are hidden from the user. Applications remain unaware of these details. On the other hand, logical data independence is harder to achieve because it allows structural and constraint changes without affecting application programs, a much stricter requirement. The three-schema architecture can make it easier to achieve true data independence, both physical and logical. However, the two levels of mappings create an overhead during compilation or execution of a query or a program, leading to inefficiencies in the database management system. Because of this, few database management systems have implemented a complete three-schema architecture. Why don't we take a break right here? We haven't mentioned the mystery word for this video, so since we've been talking about that three-schema architecture and logical and physical independence, why don't we use the term logical for our mystery word this time? Go on out, answer your mystery question, go to our coursework area and check my knowledge on the material we just talked about. And when you're ready, come on back and we will proceed with episode 5 of our discussion of database system concepts and architecture.